Somewhere out there, right now, two black holes are spiraling toward each other. And when they finally collide, it will be the single most violent event in the universe since the Big Bang. It will also be completely silent and completely invisible. A black hole is a place where gravity got so strong that nothing escapes. Not a rocket, not a laser, not light itself. Cross the edge, the event horizon, and there is simply no path back out. And black holes are not always loners. Two massive stars orbiting each other can both collapse, leaving behind a pair of black holes, locked in orbit, circling in the dark. But that orbit is not stable forever. As they swing around each other, they leak energy, and they leak it in the strangest possible way, as ripples in space itself. Losing that energy makes them fall closer together, and the closer they get, the faster they orbit, and the faster they orbit, the more energy they lose. It is a death spiral that can take billions of years. Until the very end. In the final seconds, they are whipping around each other hundreds of times every second, at a serious fraction of the speed of light. Then the horizons touch, and two black holes become one, in about the time it takes you to blink. Actually, far faster than that. Milliseconds. The newborn black hole is briefly lopsided, so it wobbles, like a struck bell, before smoothing out into its final shape. Physicists genuinely call that part the ringdown. Now, here's where it gets absurd. In one real collision we have measured, two black holes went in weighing about 65 suns combined. The one that came out weighed about 62. So roughly 3 entire suns worth of mass just disappeared. Except it did not. It was converted straight into energy, exactly the way Einstein said mass and energy can trade places. And that is where you get the number that broke my brain. For a fraction of a second, that collision radiated more power than every single star in the observable universe combined. All the stars, in every galaxy, everywhere we can see, outshone, briefly, by two dark objects smashing together. But if you had been floating nearby with the best telescope ever built, you would have seen absolutely nothing. No flash, no fireball, no sound, because space has nothing to carry sound. Because none of that energy came out as light. It all came out as gravitational waves, ripples in the fabric of space and time itself. And a gravitational wave is a genuinely bizarre thing. As it passes through you, it physically stretches space in one direction and squeezes it in the other. Then it swaps, over and over. Einstein predicted these back in 1916, and then more or less assumed we would never detect them, because the effect would be so ridiculously tiny by the time it reached us. He had a point. In 2015, a detector called LIGO finally caught one, from a collision 1.3 billion light-years away. LIGO works by shooting lasers down two 4-kilometer tunnels arranged in an L and measuring, obsessively, whether one arm gets slightly longer than the other. When the wave rolled through, it changed the length of those 4-kilometer arms by less than 1/10,000th the width of a single proton. And they measured it. The signal itself lasted about 1/5 of a second. The frequency climbed, and then stopped dead. Scientists call that shape a chirp. And if you shift that signal into the range of human hearing, it really does sound like a rising whoop. That noise is the actual sound of two black holes becoming one. So what if one happened close to us? The good news is that gravitational waves fade fast with distance, which is why the ones reaching Earth are unimaginably gentle. Get genuinely close, though, and the stretching and squeezing stops being subtle. You would be rhythmically pulled taller and thinner, then shorter and wider, which is not a great afternoon. Fortunately, nothing like that is anywhere near us. The pairs we detect are millions to billions of light-years away, which is exactly the distance I would like them to keep. What is left behind is a single, bigger black hole, spinning fast. And sometimes the merger is lopsided enough to kick the new black hole hard, flinging it right out of its own galaxy. And black holes come in far bigger sizes than these. At the center of almost every galaxy sits a supermassive one, millions to billions of times the mass of the Sun. When two galaxies collide, those giants eventually spiral together too. And this is not rare. Since that first detection, we have caught these collisions again and again. It has gone from impossible to routine in about a decade. There is also a cousin event worth knowing about. When two neutron stars collide instead, they do produce light, a brilliant flash, and a spray of freshly forged heavy elements. A serious chunk of the gold on Earth was probably made in collisions like that. Which means, as you sit there, Ripples from ancient collisions are passing through the room, and through you, stretching and squeezing you by an amount far too small to ever notice. So the universe runs both kinds. The bright ones that forge gold and light up telescopes, and the silent dark ones that simply ring space-time like a bell and move on. You are being very gently rung like a bell by black holes that merged before the Earth existed. If that rearranged your afternoon, smash that like button, subscribe to Curious Doodle, and go stare at the sky for a bit.